Hey everybody, back to another Polars tutorial. Hope you're all doing real well. Today I'm going to be continuing my tutorial series on statistical analyses using Polars and Python. We're going to be using the Polars DS, or the Polars Data Science Library again, and we're going to be studying how to do a chi-square test for independence between two categorical variables. And so that brings up the question, what is a chi-square test and when do you want to do it? So you're going to want to use the chi-square test when you have two categorical variables. And the reason for that is very simple. The chi-square test involves the use of a cross-tabulation. And so what a chi-square test is that it analyzes the difference between observed and expected frequencies in a crosstab. And so we're checking to see if there's a relationship between these two categorical variables. And so since these variables are not continuous, how can we tell if there's a relationship between them? So the first thing we're going to do is it's going to look at the observed frequencies in the crosstab, and the observed frequencies are just what's in the data. So the data I'm going to be looking at today is the college graduate data I talked about in some of my previous videos. And we're going to be looking at two variables. And the first is a variable for sex, so just male and female. And then another one for science and engineering indicator. And so this is an indicator variable that's collected by the survey that analyzes whether the respondent holds a job or educational degree in a science or engineering field. So a value of y means that they do hold a job or a degree in a science and engineering field, and a value of n means they do not. And they hold a job and fields of studies in non-science and engineering fields. And so then we have the expected frequencies. And the expected frequencies are something that's derived. And so these are the frequencies we would expect to see if there was not a relationship between the variables. And it's statistically significant if the difference between the observed and the expected is great enough. And so here's just a raw look at what our observed data looks like. This is just a frequency I put together myself. This is not the chi-square output that we're going to be looking at. And so we see that about 35% of the sample is female and works in science engineering, and 51% of the sample is both male and works in the field of science and engineering. So it does look like, even though the male population in this sample is bigger than the female population, so there is some distortion there, it looks like the female population is only about 42, 43% of the total sample, which means the remainder is male. But it does look like males are slightly more likely to be working in science and engineering. But the question is that statistically significant? Do we have enough evidence here to say that there's a relationship between these two variables of some sort or another? So just like bivariate correlation and t-test, the Polars DS package, Polars Data Science package extension that you need to have installed in order for this to work, makes it pretty easy. And so there's two arguments in it, and so I guess we'll just go over it step by step here. First, we're going to start out by creating a new data frame, and we'll point first to the input data set. So this data set is called NSCG, which stands for National Survey of College Graduates. And then .select, so we're only going to keep what's we're only going to keep what we select. And then we do PDS, Polars Data Science, .chi2, so that's chi-square. And then there's three arguments. We have the two variables that we want to create a crosstab out of. And then we have an option called return full. And return full means it returns some of the analytic data from the statistical tests that it performs. In other words, it returns the degrees of freedom and the expected frequencies. We'll go ahead and leave that as true. I'll show you what it's like if it's false. I just think the results are a lot more interesting when it keeps those. And so I'll go ahead and run this, and we'll see how that looks. OK. So here's the test statistic that it generated. There's the p-value, and that p-value is less than 0.05, and that's the standard in statistical analysis. If it's less than 0.05, then that means that's enough evidence to call it statistically significant. In other words, you have enough evidence to say that there's a relationship between these two variables. And so here's the crosstab that it generated, and here are the expected frequencies that it was expecting to the observed data to be close to if we were to be able to say that there was no relationship between these variables. And so if there was no relationship between these variables, we would expect males to be working in science and engineering statistics at a rate of, a frequency of 44,000. Instead, we have a frequency of 45,000. And we would expect the female number to be 33,000 instead of 31,000. So since there's a big enough difference between the observed and the expected frequency, there's enough evidence to say that there's a relationship between these two variables. Okay, guys, that's really all there is to doing a chi-square analysis in polars using Python. Not a lot of options, and the output is very informative. So thanks so much for watching, and have a good rest of your day.